You know what's mind-blowing? Modern aircraft have systems so sophisticated that they can actually fly with certain equipment not working, and it's completely safe. Today we're exploring how that's even possible.
Well, that's fascinating and probably terrifying to most passengers. How exactly does that work?
So here's the thing. Commercial aviation has this incredibly detailed system called the Minimum Equipment List, or MEL, which spells out exactly what can be inoperative while still maintaining complete safety. Think of it like having redundant systems in a space station.
That makes me think about all those times flights get delayed for mechanical issues. I guess they're really following strict protocols there.
Exactly right. And what's really interesting is how they categorize these issues. They have 4 different levels, from Category A, which means fix it now, to Category D, which gives them up to 120 days to make repairs. It's all about balancing safety with practical operations.
You know what's really intriguing about this whole system? The way it reflects how aviation has evolved from experience. Every rule probably exists because of something that happened in the past.
That's exactly right. And speaking of evolution, let's talk about something that affects every single flight, but most passengers never think about: the center of gravity calculations. Did you know that even where passengers sit can affect how efficiently the plane flies?
Well, that certainly explains why they sometimes move people around before takeoff. How significant is this effect?
So here's a fascinating statistic on larger aircraft like the A330. Having the center of gravity in the wrong place can waste hundreds of kilograms of fuel on a single flight. We're talking about 220 kilograms. More fuel burned on just a 1,000 nautical mile trip if the weight distribution isn't optimal.
That really adds up when you think about how many flights happen every day. Must be a huge environmental and economic impact.
And here's what's really wild. Pilots have to consider this along with dozens of other factors during their pre-flight preparations. They've got this whole choreographed routine they follow, using something called SPIT, scan, program, instruments, takeoff, briefing.
That's quite a mnemonic device. How do they manage all these complex calculations while also dealing with everything else that's happening before a flight?
Well, that's where modern technology comes in. The flight management system helps with a lot of the heavy lifting, but, and this is crucial, pilots still have to understand all the underlying principles. They can't just blindly trust the computer.
So what happens if something isn't quite right during all these checks?
That's where it gets really interesting. They have this incredibly detailed system of amber warning boxes on their displays, kind of like warning lights in your car, but way more sophisticated. And get this, even the oxygen system has multiple layers of warnings that kick in long before there's any actual problem.
Well, that certainly explains why we sometimes see pilots going through what looks like an endless checklist before takeoff.
And you know what's fascinating about those checklists? They're designed with human psychology in mind. The tasks are divided between the 2 pilots in a way that ensures everything gets double-checked without creating information overload.
Speaking of the 2 pilots, how do they divide up all these responsibilities?
So they use this brilliant system where one is designated as pilot flying and the other as pilot not flying. But here's what's clever, both are constantly cross-checking each other's work. It's like having a built-in safety net.
That must require incredible coordination between them.
Oh, absolutely. And what's really fascinating is how they've developed specific communication protocols. Like they have to use clear, standardized phrases to avoid any possibility of misunderstanding. Even something as simple as confirming a number has to be done in a specific way.
Well, that makes me think about all the different accents and languages in international aviation. How do they handle that?
And that's actually another fascinating layer of aviation safety. They use what's called Aviation English, which is a standardized form of English with specific vocabulary and pronunciation rules. But even beyond language, they use visual confirmations for everything critical.
You mentioned earlier about systems that can be inoperative. How do pilots keep track of all that?
So here's where it gets really interesting. They have this comprehensive documentation system that uses something called ATA codes. Think of it like a massive library where every single system on the aircraft has its own unique address. For example, 21-52-01 tells you exactly which air conditioning pack you're dealing with.
That level of detail is incredible. How long does it typically take pilots to learn all these systems?
Well, the initial training is intense. We're talking months of study just to learn the basic systems. But what's really fascinating is how they've designed the cockpit to help pilots manage all this complexity. Everything is arranged in a logical flow pattern, and the most critical systems are always the most accessible.
That makes me wonder about how they handle emergency situations with all these interconnected systems.
Now that's where all this preparation really pays off, because they understand how all these systems work together. They can make informed decisions even when things don't go as planned. And here's what's really clever. The aircraft's computers are programmed to help manage complex situations while still leaving the pilots in ultimate control.
Sounds like an incredible balance between human expertise and technological assistance.
You know what's really remarkable about all this? How it all comes together to create one of the safest forms of transportation ever developed. Every single detail, from the way they arrange the cockpit to how they manage system failures, is part of this massive safety net.
Well, that certainly gives me a new appreciation for what's happening in that cockpit before takeoff.
And that's really the key takeaway here. Modern aviation safety isn't about any one thing. It's about layers upon layers of systems, procedures, and checks, all working together to ensure that even if something isn't perfect, the flight can still be conducted safely.